There are three main approaches to machine learning. The first is called supervised learning. In this type, the learning happens from the data that contains both inputs and expected outputs. In the second type, called unsupervised learning, the data contains only the inputs and the algorithm learns the hidden structure in the data. Finally, the third type is called reinforcement learning. In this type, it learns how an agent should take action in a given environment, such that it maximizes the reward function. Next, we will look at the different subtypes of machine learning approaches. One of the most common type of supervised learning is classification. In this type, the output is categorical. For example, from a set of emails, you want to classify each email as either spam or not spam. The second common type of supervised learning is called regression. In this case, the output is numerical or continuous. For example, predicting a value for a used car using various input features such as make, model, year, miles. Some of the other types of supervised learning include similarity learning, where it learns from examples using a similarity function. This type of learning is applied in ranking or recommender systems. Next is feature or representation learning. Feature engineering is one of the core techniques that can be used to increase the chances of success in solving machine learning problems. Having the right input features is a critical prerequisite for training high-quality models. Feature learning is used to transform sets of inputs into other inputs that are potentially more useful in solving a given problem. Lastly, we have anomaly detection as a type of supervised learning. It's a special type of classification problem where it learned what's normal and what is anomalous using labeled dataset. This considered its own type because number of entities in the anomaly class is several order of magnitude smaller than that of the entities in the normal class. That makes training high-quality models more difficult than in most other cases of classification. Clustering is the most common type of unsupervised learning. In this problem, the goal is to find inherent groups or clusters within the data while maximizing intra-cluster similarity and inter-cluster dissimilarity. One example of clustering is grouping customers with similar purchasing habits for developing a more effective target marketing campaign. You can use unsupervised learning to also learn more useful features based on unlabeled dataset. Clustering is also considered a form of feature learning since the clustering identifier is actually a new feature generated for each entity in the dataset. The unsupervised approach of anomaly detection is fundamentally a problem of identifying two major groups of entities, the normal ones and the abnormal ones, the anomalies. The unsupervised approach of anomaly detection is based on using a training data set that has no normal/anomaly label available. It works under the assumption that the number of entities in the anomaly class is several orders of magnitude smaller than that of entities in the normal class. The reinforcement learning approach is concerned with optimizing the actions of a software agent operating in a given environment such that a given reward function is optimized. In most cases, the environment in which the agent is acting is modeled as a Markov decision process that does not assume knowledge of an exact mathematical model. The most important characteristics that differentiates reinforcement learning from both supervised and unsupervised learning is its active in nature. Supervised and unsupervised learning are passive approaches where learning is performed without any actions that could influence what data could be observed in the future. Reinforcement learning is an active approach where the actions of the agent influence the environment, hence the data that could be observed in the future, hence its own potential future states. As a result, reinforcement learning is appropriate in scenarios like game and control theory, robotics, and autonomous driving.